First of all, recall the formula of sin 2a, cos 2a and tan 2a. So first formula, sin 2a is equal to 2 times sin a into cos a. Second one, cos 2a is equal to, we get total 3 formula. So first formula, cos square a minus sin square a. Second formula, 1 minus 2 sin square a. Third formula, 2 cos square a minus 1. Third one, tan 2a is equal to 2 tan a upon 1 minus tan square a. Now, related to this formula, discuss one question. First question, find the value of cos for x. So is equal to cos 4x in place of written here cos 2 into bracket 2x is equal to, now we know that cos 2 theta is equal to, actually our proof is cos 2a is equal to 1 minus 8 sin square x into cos square x. So prove that cos 4x is equal to 1 minus 8 sin square x into cos square x. So now first of all start from the LHS side. Cos 4x in place of written here cos 2 into bracket 2x. Now we know that one identity cos 2 theta, actually cos 2 theta is equal to 3 identity present, but here our proof is 1 minus form is present. So here we can using by the formula 1 minus 2 sin square theta. Now here theta in place of we can consider 2x. So substitute the value in this equation. So 1 minus 2 sin square and theta in place of written 2x. Now we can also written 1 minus 2 sin 2x whole square, because sin square theta is equal to, we can return sin theta whole square also. Now we know that sin 2 theta is equal to 2 times sin theta into cos theta. So same identity, sin 2x in place of apply here. So is equal to 1 minus 2 in bracket 2 times sin x into cos x and whole square form is present. So written here whole square is equal to 1 minus 2 into bracket 2 raised to square, that means 4 sin x whole square. So written here sin square x into cos x whole square, so cos square x. So is equal to, now open this bracket, so 1 minus 4 to the 8 sin square x into cos square x is equal to RHS side. Next question. Prove that tan 4x is equal to 4 tan x into bracket 1 minus tan square x upon 1 minus 6 tan square x plus 10 raised to 4x. So again start here LHS side. Tan 4x. Now tan 4x in place of written here tan into bracket 2 into bracket 2x. Now here written the formula tan 2 theta is equal to 2 tan theta upon 1 minus tan square theta. So now here theta in place of consider 2x. So substitute the value tan 2 theta in place of 2 tan theta in place of 2x upon 1 minus tan square theta. So written here 2 times tan theta in place of 2x upon 1 minus tan square theta in place of written 2x. Now again same identity apply here. Tan 2 theta is equal to 2 tan theta upon 1 minus tan square theta. So written here is equal to 2 into bracket tan 2x in place of written 2 tan x upon 1 minus tan square x bracket over upon in denominator term 1 minus tan 2x in place of written here 2 tan x upon 1 minus tan square x whole square is present, so we can return here whole square. Now after take LCM of this term, so 2 to the 4 tan x upon 1 minus tan square x upon in denominator term LCM is 1 minus tan square x whole square. So written here upon 1 minus tan square x whole square, and here LCM is not present, so multiply 1 with 1 minus tan square x whole square minus now 2 tan x whole square, that means 4 tan square x. Now here simplify this term, so is equal to 4 tan x upon 1 minus tan square x. Now this term present in division form, so convert into multiplication form. So 1 minus tan square x whole square we can return in numerator. So 1 minus tan square x whole square upon in denominator open this bracket and simplify this term. So here apply the identity a minus b whole square, that means 1 minus 2 tan square x plus 10 raised to 4x minus 4 tan square x. Now here one term cancel out, so in numerator remaining term 4 tan x into bracket 1 minus tan square x upon in denominator term 1 minus 2 tan square x minus 4 tan square x, that means minus 6 tan square x plus 10 raised to 4 x. So our proof is means our RHS side 4 tan x into bracket 1 minus tan square x upon 1 minus 6 tan square x plus 10 raised to 4x, so is equal to written here RHS side. Next question. Prove that in bracket sin 3x plus sin x bracket over sin x plus in bracket cos 3x minus cos x bracket over cos x is equal to prove that 0. So again start from LHS side. Now here in first bracket apply the identity s plus s. S plus s, that means 2sc. So here written 2 times sine in bracket 3x plus x divided by 2 into cos bracket 3x minus x divided by 2 whole bracket over. Now in outs multiply sin x plus c minus c. C minus c, that means minus 2ss. So here apply the identity minus 2 times sine into bracket 3x plus x divided by 2 into sine bracket 3x minus x divided by 2 bracket over whole bracket over into outside we can written here cos x. Now after open this bracket simplify this term. So 2 times sine 3x plus x divided by 2. So 3x plus x, that means 4x divided by 2. So here returns 2 times sine 2x into cos x into sin x minus, same way here, minus 2 times sine 2x into sin x into cos x. Now both these terms same, so cancel out these terms, so is equal to, we get answer 0 is equal to written here RHS side. Next one, prove that cos x plus cos y whole square plus sin x minus sin y whole square is equal to 4 cos square into bracket x plus y divided by 2. So again start here LHS side. So in first bracket c plus c form is present. So c plus c is equal to, in first bracket apply the identity 2cc, and in second bracket s minus s form is present. So here apply the identity 2cs. So is equal to c plus c. So here we can written 2 times cos x plus y divided by 2 into cos x minus y divided by 2, and whole square is present, so written here whole square, plus in second term sin x minus sin y whole square. So here apply the identity s minus s, that means 2cs. So here written 2 times cos into bracket x plus y divided by 2 into sin bracket x minus y divided by 2 bracket over whole square. Now here simplify this term. So 2 whole square, that means 4 cos square into bracket x plus y divided by 2 into cos square bracket x minus y divided by 2 plus 2 square, that means 4 cos square x plus y divided by 2 into sin square bracket x minus y divided by 2. Now which term common in both these term? So here common term is 4 cos square x plus y by 2. So we can take common. So 4 cos square into bracket x plus y divided by 2. Now remaining term written in another bracket. So remaining term cos square into bracket x minus y divided by 2 plus sin square bracket x minus y divided by 2 bracket over. But we know that sin square theta plus cos square theta is equal to 1. So here apply this identity. Cos square, this term we can consider in form of theta because both these term are same. So here we can apply this result. So sin square theta plus cos square theta 1. So this term is we can written 1. So 4 cos square theta cos square bracket x plus y divided by 2 into bracket 1 is equal to RHS side. Next one, prove that cos x minus cos y whole square plus in bracket sin x minus sin y whole square is equal to prove that 4 sin square bracket x minus y divided by 2. So again start from LHS side. In first bracket apply the identity c minus c, that means minus 2ss, means minus 2 times sine into bracket x plus y divided by 2 into sine bracket x minus y divided by 2 bracket over whole square. In between plus sign, so written here plus sign. In another bracket s minus s, that means 2cs. So here written 2 times cos x plus y divided by 2 into sine x minus y divided by 2 bracket over whole square. Now simplify this term. So minus 2 square, that means 4 sine square into bracket x plus y divided by 2 into sine square bracket x minus y divided by 2, in between plus sign, 4 cos square into bracket x plus y divided by 2 into sine square bracket x minus y divided by 2. So is equal to which term common here? So here common term 4 sin square x minus y divided by 2. So written here 4 sin square bracket x minus y divided by 2. So now remaining term sin square into bracket x plus y divided by 2 plus cos square bracket x plus y divided by 2. Now sin square theta plus cos square theta is equal to 1. So written here 4 sin square into bracket x minus y divided by 2 is equal to RHS side. Okay. Now today we are going to discuss the formula of sin 3 theta, cos 3 theta or tan 3 theta. That means sin 3a, cos 3a and tan 3a. So let us discuss this formula. So first result sin 3a. Sin 3a is equal to 3 sin A minus 4 sin cube A. Now short form of this formula 34. Second formula, cos 3A is equal to 4 cos cube A minus 3 cos A. Short form of this formula 43. And third formula, tan 3A is equal to 3 tan A minus tan cube A upon 1 minus 3 tan square A. So now related to this formula, discuss one question. Find the value of, means prove that cos 6x is equal to 32 cos raised to 6x minus 48 cos raised to 4x plus 18 cos square x minus 1. So start LHS side. So cos 6x, in place of written here cos 2 into bracket 3x. Now our proof is present in form of cos form, and we here cos 2 theta formula apply here. So cos 2 theta is equal to, total 3 formula is present, but our proof is present here, cos form is present. So here apply the identity, cos 2 theta is equal to 2 cos square theta minus 1. So is equal to, written here 2 cos square theta in place of 3x minus 1. 2, here we can written cos 3x whole square minus 1. Now apply the identity cos 3a, that means 4 cos cube a minus 3 cos a. So here apply this identity. So 2 into bracket 4 cos cube x minus 3 cos x bracket over minus 1, and here whole square is present, so written here whole square. Now after apply the identity a minus b whole square, so is equal to 2 into bracket a minus b whole square, that means 16 cos raised to 6x plus 9 cos square x minus 4 3 is 12 into 2, that means 24 cos raised to 3x into cos x, that means cos raised to 4x bracket over minus 1. Now simplify this result. So is equal to 2 multiply in this bracket, so 16 into 2 means 32 cos raised to 6x plus 9 to the 18 cos square x minus 24 into 2 means 48 cos raised to 4x minus 1 is equal to RHS side.